In this video, we're going to look at colligative properties. And colligative properties are properties of a solution that change when something is dissolved in that solution. And the reason why they're colligative is because it does not depend what you dissolve in your solution. So, for example, you could dissolve salt in water. You could dissolve acid in water. You could dissolve chocolate in water. It doesn't matter. The colligative properties such as vapor pressure, freezing point, and boiling point in osmotic pressure will all change. It does not matter what you dissolve. All that matters is how much stuff you dissolve. For example, in cooking, you add salt to water when making pasta, not only to flavor it, but it'll also slightly raise the boiling point of water because of colligative property. And this all is due, these colligative properties are all due to these intermolecular forces we've been talking about. So the first colligative property we're going to talk about is vapor pressure. And when comparing a pure solvent to a solution, the solution has a lower vapor pressure than the solvent. And it doesn't matter what you dissolve in the pure solvent, since this is a colligative property, the vapor pressure will always decrease. And let's think about why. So we're in a closed system here. We have a liquid and a gas, and you're going to have a dynamic equilibrium between evaporation and condensation, as we talked about in Chapter 11. Now, that's for a pure solvent. Let's say you dissolve something in your solvent. That's what these red beads are. Now, you're still going to have some kind of vaporization and condensation happening. But remember, in Chapter 11, we said only the molecules at the surface of your solution will become gas. Well, if you dissolve something in your pure solution, there are less solution molecules at the surface. Therefore, your rate of vaporization slows down. And eventually, you'll have a new equilibrium for your new rate of vaporization and condensation, but overall you'll have less gas molecules in your vapor phase in a solution than you do for a pure solvent. And we can measure this, and we have an equation to use for this, and it's called Raoult's law. And Raoult's law says the vapor pressure of a solvent, and it has to be volatile, and remember, volatile means that it'll form into a gas. Well, that pressure is equal to the mole fraction of your solvent multiplied by the pressure of the pure solvent. Now, mole fraction will always be less than 1 in a solution, because you can't have more than 100% of a solvent in a solution. So that is why the pressure of your solvent in your solution is less than your normal pressure. And let's walk through an example for this. So let's say we have a solution that is 24.5 grams of glycerin. That's dissolved in 135 milliliters of water at 30 degrees centigrade. Now, the vapor pressure of pure water at 30 degrees is 31.8 torr. Now, we're going to assume glycerin is non-volatile. That means it will not form a gas, and it dissolves molecularly. That is, every one molecule of glycerol, when it dissolves, does not break apart. And we're going to assume that the density of water is 1 grams per mil. So to solve this, we need to use Raoult's law. But the first thing we need to do is figure out the mole fraction of water that we have. So to do that, the first thing I need to look up or figure out, what is the molecular weight of glycerin? Well, that's 92.09 grams per mole. If you do not know how I got this, please refer back to the earlier chapters in your book, as this is something we covered in Gen Chem 1 extensively. From that, I get moles of glycerin. as above, we covered how to go from grams to moles extensively in Gen Chem 1, so please review if you do not know how to do that. Weight of water is 135 grams, so the moles of water I have is 7.5 moles. So my total moles is 7.77. Therefore, my mole fraction for water is 0.965, which is just 7.50 divided by 7.77. Now, I find out from my problem, pure water has a pressure of 31.8 torr. So using Raoult's law, the vapor pressure of the solution is my mole fraction times my pure pressure, which is 30.7 torr. And that's it for this video, and I'll see you in the next one.